You are offered an investment which will pay $722 in 1 year, $433 the year after that, and $865 in the final year after that. However, you will not see any returns in the first 2 years. What is the most you should pay for this investment, considering that you can earn 2.7% on similar investments? Conceptually, this question is quite straightforward as long as we follow our simple 3-step process. Our first step is to put the cash flows on a timeline so that we're aware of when the cash flows are coming in. The question tells us that the first 2 years we get no returns, so that means that 0 is the value of the cash flow for the first 2 years. Then it tells us that we have 3 cash flows of 722, 433, and 865. This is our first step done. Our second step is to discount each cash flow. We do this by multiplying it by the present value interest factor, or 1 over 1 plus r raised to n. The r value is equal to 0.027, or 2.7%. The n value depends on the cash flow. So, for example, our year 3 cash flow would have an n value of 3 because there are 1, 2, 3 periods between it and the present day. And our year 4 cash flow would have an n value of 4 and our year 5 of 5. So let's discount our cash flows. The present value for our third year cash flow should be 722 over 1.027 raised to 3. That should give us a value of $666.54. Similarly, for year 4, we should have a value of $389.23. For year 5, we should have a value of $757.12. When we sum these up, which is our final step, we get the total present value. That is equal to $1,812.89. There's our answer. If our required rate of return is 7%, what is the value of an investment that pays $5,000 annually for 12 years? For 15 years? Forever? So in this problem, we have to realize that we're dealing with an annuity, and as such, we have to use the present value of annuities formula, which is given to us by C times 1 minus 1 over 1 plus r raised to n, all that divided by r. In our case, we want to find the present value of after 12 years. So we would plug in the values of 5,000 times 1 minus 1 over 1.07 raised to 12 over 0.07, and that should give us a value of $39,713.43. Similarly, when we're calculating the present value for 15 years, we would keep all these variables the same. It would look exactly like this, except the exponent here would change to 15. And that should give us a value of $45,539.57. Now, when it asks us to calculate the present value as if the payments continued forever, it's really asking us what would happen if this was a perpetuity. In that case, we would use the formula for the present value of a perpetuity, which, as we know, is super simple, C times 1 over r. So in our case, 5,000 times 1 over 0.07, which should give us a value of $71,428.57. You're deciding between an annuity that pays $5,000 annually for 10 years and a perpetuity that pays $2,500 annually. Both pay out at the end of the year. At what discount rate would you be indifferent about purchasing the annuity or the perpetuity? So really what we're being asked to do in this question is decide when the present value for the annuity is equal to the present value for the perpetuity. And since the r value is the one that we don't know, we're being asked to determine what is that r value. And so the way that we would do this is by expanding each side. So we have the cash flow for the annuities times 1 minus 1 over 1 plus r raised to n divided by r should be equal to the cash flow for the perpetuities times 1 over r. And when we plug in our values, we have 5,000 times 1 minus 1 over 1 plus r raised to 10 over r is equal to 2,500 times 1 over r. And now what we're trying to do is isolate for r. Suffice it to say that when we do, we get r is equal to 0.072.
That brings us to the end of the video. Still confused? Rewind to the relevant part of the video by clicking on the sections listed to the left. For more, be sure to take a look at the tip sheets uploaded to the Academic Success Center website by following the link in the description.